Okay, good morning everybody. Welcome back to lecture number 3, where we start the serious stuff today. And hopefully our goal is to finish KCL and KVL. Okay, we will review the options once we solve one problem. The passive sign configuration, option 1, option 2, option 3. Okay, we did the energy. Today we talk about KCL. So, a node is where we connect 3 elements, 4, 2, 1, any element. So if you have element here, you have element there, you have element here, this is called a node. The node, okay? If you connect only another element, this is also a node. Now, this node is vertically connected, the boundaries of it, all the way here. Why? Because conductors have 0 voltage drop. So if you connect, actually if you touch it here, it's like touching it there. If you touch it here, it's like touching it here, okay? But in schematic drawings, we try to make it nice. We make angles, and then if we connect 2 elements, we put a ball or dot. We call this a node. And sometimes it's better to name it. This is A, maybe this is B, this is C. So, in every node, the summation of current entering and leaving should be 0. So 2 ways of doing it. Either you can say in minus out equals 0, or, this is confusing, I think the best way is to call it in equal out. What does that mean? It means whatever current is entering I1 plus I2 equal to I3. I3 equal to I4 at node B. At node C we have I5 plus I6 plus I7 equals 0 because we have 0 currents leaving. So I prefer this. You can do in minus out, but this is confusing. Just put in equal out, but write the word in equal out. And then what is in? I5 plus I7 plus I6 equal out. Is there anything coming out? No. Out means away from the dot. Get it? That's a KCL in a nutshell. The sum of the currents entering the node equals to the sum of the current leaving the node. Now, you can do it with the method that I do not like, where we call it minus I1 minus I3 plus I3 equal. It's stupid. I prefer I1 plus I2 equal to I3. I1 plus I2 equal to I3. So this method is better, you can see now. Because some of you will put minus and then you will lose unnecessary points doing it. In other words, it's like saying all the currents entering and leaving should equal to 0. Okay? Sometimes what we have called a giant node. A giant node is, you have, for example, this one has 4. As I told you, touching it here is like touching it there, it's like touching it here. The node itself, this is all called a node. But where we connect the actual cables is where we put the dot. We can make this dot big. And this method is IA plus IC in equal to out. ID equal to ID plus IB. All points in a circuit that are connected directly by conductors can be considered to be a single node. So you can make it big, you can make it small. And over time, you should not worry about drawing the dot.
How do we have a node when we have only 2 circuit elements connected together? It's like a straight line.
Yeah, but it counts as a node because the definition of a node if you connect 2 elements or more. 2 elements or more.
So if you have a straight line, there is a node.
Yeah, if you have a node of 2 elements, usually the current is going to be the same because in equal out. And we will see in the examples. We'll solve examples today and they will show you how it looks like. Get it? So two elements, still a node. You're talking about this example. Usually in the exam, they put tricks. They put I4 and I3 opposite of each other. That's a common trick I've seen in the textbook problems. And by the way, I promised you all the quizzes will be from the textbook. Same numbers. To encourage you guys to study the textbook, okay? Maybe we'll change one or two numbers, but the problem will be the same. But for quiz 1, it will be exactly the same from the book. So let's do it by brain without writing it. 1 plus 3 equal to? 4. So IA equal to 4. 3 plus 1 is 4. Minus 2 is 2. Oh, no.
Plus I.
Okay, again, don't confuse. 1 plus 3 plus x equal to 2. Solve this linear equation. So it means minus 2. So minus 2 plus 3 is 1. Plus 1, 2 equal to 2. You can do it by brain. Always double check. Always double check. Once you solve a problem, double check. Let's substitute IC minus 8. Minus 8 plus 1 is minus 7. Plus 4 minus 3. Minus 3 or equal to 3 because it's in. This is the only in. This is all the out. In the exam, maybe it's better if you have colors. Then you can color whatever in, whatever out. That's a good strategy. So you know how to do this exercise? Okay, series and parallel. If two elements are in series, it's like having pipelines that are welded together. If they are in parallel, it means they share two nodes. So series, they share one node exclusively. They are in series if they share one node exclusively, just بس واحدة. No third element is sharing it with them. Parallel, 2, 3, 4, infinity elements, they share two nodes. And they are side by side, موازية, okay? So we can say A, B, and C, they are parallel. What is the main feature? They're series. What is the major feature of series elements? They share the same current. IA equal to IB equal to IC. The same current is flowing. The same water.
The same voltage vector also.
No, this is for the current. They don't have the same voltage. As a matter of fact, when we do KVL, you will find that the voltage drop here is actually the voltage drop here plus here plus here. But for the current, they have the same current. Why? You can go to node 1. IA equal to IB. Node 2. N equal out. IB equal to IC. Get it?
Yes.
Anybody doesn't understand? Yes, please.
I have a question. What will happen? We have one node and the current is opposite, but one current is bigger than the other.
That doesn't exist. You cannot have a circuit that has two elements, maybe IA equal to 5 and IB, which is opposite in direction, equal to 3. That doesn't make any sense because it violates KCL. Is 5 equal to 3? No, that does not exist. D and E does not exist. It doesn't exist. You can't have a flow in a pipeline if you measure it from one direction equal to the other direction. It doesn't equal to the other direction. Now if you have a third element, yeah, this can happen. That's the whole idea of KCL. Okay? Okay guys? Now let's try to solve this textbook problem. Which elements are in series? We have A and E in series. We have C and D in series. B doesn't have any series element. Okay? What is the relationship between ID and IC? Put a node here. N equal out. So what is N? N is 0. Equal to IC plus ID. So the relationship is, again, N equal out. I want you to write N equal out. What is N?
0.
N 0. What is out? IC plus ID. So the relationship IC equal to minus ID. In equal out, okay? Now, given that IA is 6, what is IA? This is IA, 6, IC is minus 2, so determine the value of IB and ID. Well, we have an easy problem. We can calculate ID. ID is plus 2 from that relationship. So we have ID equal to plus 2. Okay, we don't care about ID. Now we have IC. So what is IB? In equal out. In equal out. What is N? IA
6.
and this node. Say IA, just write the letters first, plus the variables. IC equal to IB. What is IA?
6.
Plus. What is IC?
Minus.
So you get the answer to be 4 amps, which is IB. No. IA, the arrow is entering the node. IC is entering the node. In. IB is leaving that node. IB is leaving. Get it? واضحة? Consider the circuit of figure I-23. Identify the group of circuits that are connected in series. What we have? A and B are in series. E and F and G are in series. Okay? E, F, G, series. A and B in series. C and D, they do not have series elements. بالتسلسل. You did it in high school, صح? Parallel circuits, two elements, they share the same two nodes. Or infinite elements. It can be 3, it can be 1 million. So look at this lamp. Let's call this A, B, C, D, E, F, G, H, I. Now it's connected in a grid, صح? Let's say that there is no cables from that way. All the cables are connected this way. So we have A, B, and C are series. These three are in series, these three are in series. Now the whole three is in parallel with those three, is in parallel with those three. Get it?
Yes.
So you can have maybe A, B, C parallel. The whole group is parallel with B, C, D, like the classroom now. This is a bigger example. But to make it simple, is that parallel circuits, in a simple explanation, they share the same voltage drop. So if you put two probes here, you'll get the same voltage here and there. And this is a common trick to find the relationship between voltages. Is, oh, those are in parallel, they have the same voltage. So VAB, VA, the voltage across A, equal to the voltage across B, and the voltage across A equals to B equals to C. Get it? Okay. The voltage across A, what did we call it? VA. Now, here we didn't put the letters and the notes. Here we call it voltage of element A equal to the voltage of element B, because it's the same connection. The same wires connected. Wires are short circuits. These two nodes are the same. ما في element بينهم. لو حطينا element هنا ما صاروا the same node. C is connected to the same node. هنا لا يغرك حاط دائرتين بس عشان المسافة. ولا هم هذه الدوت هي نفس هذه الدوت. هذه الدوت هي نفس هذه الدوت. كأنك توصل بالأسلاك. تمام؟ Equal to VC. Is it clear? Okay. What do we have here? We have A and B in parallel. We have D, E, and F are in parallel. So, A and B, if you combine them in a big box, black box, it will be in series with C. And the whole three, if you combine them in one box, it will be in series with C and the combination of A and B. We'll talk about this concept later. But in electrical engineering, sometimes we simplify, reduce the elements. From those parallel, we combine them to one element. We call it A comma B, for example. We can call it A comma B means A and B together. In series with C, in series with another box, we call it D comma E comma F. Those are now in series. So we have simplified a network to a simpler network. And this one is usually easier to solve than this one. And this is what we're going to study in the few days.
So what about B and C alone? Small b and small c.
B and C alone, they are neither. Because do they share a single node? No. Do they share two nodes? No, they don't. This has this node which is separated by this node. Now these three dots are single node. But because the drawing is square, we separate them. So this node is that node. These two nodes are the same. This node is the same. So how many nodes in the system in reality? Three. In reality we have 1, 2, 3 nodes. So ask yourself, are they in series? Do they share a single node alone? No. Do they share two nodes even with each other, even with others? Like for example, D and E. Do they share two nodes? Yeah, but also they're sharing it with F. It doesn't matter. I told you they can share it with infinite number. So is it clear the concept of parallel versus? Checkpoint. This is a problem from the book. So what is this problem? 1.37. So the first part of the question is, use KCL to find the values of IA, IC, and ID. Okay, answer. معلش. Is it clear? إذا شيء مو واضح قولوا زومين عادي ما مشكلة. So what we have here? We have IA equal to -2. تمام? So now we found IA. What is IC? IC, N equal out. What is N equal out? So we finished IA. IA is easy. Let's solve IC. N equal out. What is N? This node. Now again, don't confuse yourself. This node, we're spacing it, but it will have the summation of the current flowing inside it. Now, this is a tricky problem. That's why I wanted to show it to you. N equal out. Let's pick this node. For KCL, pick this node. I know I told you these two nodes are the same, but because we're sparing them with a cable, we're zooming inside this big node to see the current that flows. So you can say equal to 3, out. What is N? 2 plus IC. So IC is 1. Let me check. IC equal to 1. And then we have ID. So how to do ID? N equal out. Pick a node. You want to pick this node or that node? You want the corner?
Yes.
Okay. N equal out. At the corner. So N is what? 3 plus 1 equal ID. So ID is amps. Don't forget the unit. And put the units with brackets. تمام? Put the units with brackets. أحسن. So the last question, which elements are connected in series? A and B. Is KCL clear? So, A and B are in series, C is alone. Okay, C and D, are they parallel?
Yes.
Yes. D and E, are they parallel? Yes. E and C, are they parallel?
Yes.
Yes. Because this node is same as that node, but we are showing the current that flows inside the dot. Inside the dot. Showing the current that flows inside the dot satisfies the relation in equal out.
So for simplicity, we can't redraw the D.
You can redo it, but in the exam you will not have enough time. So it's better to absorb these concepts mentally and train yourself. I highly recommend you not to redraw the circuit. When we provided the circuit, we provided you in the best interest. Over time you will get experience with it. Okay?
So, Doctor, We can shift this D block to be vertical, yeah.
Yeah, you can, but if you show it vertical, it would, the trick is to show it diagonal, but you can do it, you can fix it this way. But the I3 will have a smaller, this cable will have a smaller, and then we will not have enough. It's a trick. Now, these are very common, the diagonal elements, if you have instrumentation. And instrumentations, they love having diagonal elements. طيب يا شباب؟ تمام? So what is KVL? First of all, Kirchhoff's voltage law is a KVL. So we finished KCL. KVL. Let's start with the concept of a loop. What is a loop? Loop يعني لفة. Loop يعني لفة. So imagine yourself, let's redraw this element. A, B, C, D, and E. And this is me, okay? I can take a loop over the whole system and come back. This is loop 3. I can walk here across this, so this is loop 2. Or I can start from here and go over this loop. You need to, once you walk over the elements, you need to stop. Once you walk over your elements, you need to stop. Get it? So how many possible loops here? 3. Can you find a 4th loop? No. So is the concept of a loop clear? Now what is KVL? KVL in a nutshell is if you walk over a loop, the summation of the voltages that you face is 0. إذا مشيت على اللفة مجموع الجهود اللي تمر عليها تساوي 0. And how do we write these equations? It's very simple. But before that, I want to tell you something about voltage rise and voltage drop. If I'm walking, so let's say we have A here and we have plus and minus, we call it V little a. They call it V little a, which we call it if you put the dots A, B, but for now, and I am here. What do I experience? A voltage rise or a voltage drop? A voltage rise, ارتفاع في الجهد. I'm at a low pressure. I'm experiencing a voltage rise. So in the KVL, if you experience a voltage rise, you add plus VA. Now, let's say I'm at an element B. So this is me, I finished walking over element A, I'm walking at element B. And this is me. Plus minus, we call this VB. Am I experiencing a voltage rise or voltage drop? Drop. So I say minus VB. So if you experience a voltage rise, you add a rise. You're rising. You're gaining voltage. If you experience a voltage drop, you lose voltage. So this is better than the other argument. They say, oh, if you see a minus sign, put a minus sign. No, that doesn't make any sense. Nothing in life, if you see a negative sign, you put a negative sign. So you'll go with this logic because it makes more sense. It makes more sense if you experience a voltage rise to add a positive value. Now, ending with D, I'm here. Is it a voltage rise or voltage drop?
Right.
No, I'm going from top to bottom. Drop. So it's going to be a negative. So what to say is the book tells you it's minus VA plus VB plus VC. Don't follow the book. Yes, I'll answer your question. What is your question?
What if one of the elements is a battery? Then the voltage difference will be 0, right?
Yeah, if element A was a battery, is it a voltage rise or a voltage drop?
No, I mean the signs doesn't indicate.
Forget about the signs. Do what I'm telling to you, because in the book it tells you here minus VA because you see a minus, and then it tells you plus VB because you see a plus. That's wrong. Not wrong, but I don't like it. I am here. Draw yourself. So let's take loop 1. A, B, and C. This is plus minus VA, plus minus VB. This is given to you. And in loop 1, so I start from, let's start from here, okay? So this is me. I'm walking here. Am I experiencing? First I walk across element B. Is it a voltage rise or voltage drop? So minus VB. I am now here. I'm going down. Drop. Minus VC. I am here, صح?
Yes.
Am I seeing any element here?
No.
So 0. So I'm here. Am I seeing the voltage rise or voltage drop?
Right.
Plus VA. Actually, this equation is same as this equation, but we multiply it by minus 1. Because of the logic that I'm telling you. Which one makes more sense? Which one are you going to do? This one makes more sense. Am I gaining voltage? Am I losing voltage? Trust me, if you follow this approach and stick with it, you will be way better than the thing, oh, am I seeing a negative? Put negative? No, that doesn't make sense. Get it? So let's do, without writing on the board, the other two loops. So equation 1 refers to loop 1. Equation 2 is what? I'm here. It's going to be plus VC plus VD. I'm experiencing a voltage rise.
Yes.
Minus VE. So the way they did it here is minus VC minus VD plus VE. It's the same, just multiply by negative 1. The outer loop, VA minus VB plus VD minus VE. Again, I'm here. Voltage rise plus VA, voltage drop minus VB, voltage rise plus VD, voltage drop minus VE equal to 0. It's the same equation as loop 3.
If I'm gonna use a rise and drop approach, should I multiply after I finish it?
No, do not multiply by minus 1. You can keep the same equation. If I tell you these equal to 0, it's the same. Now it's up to you. If you want to use the book approach, use it. If you want to use my approach, you can use it.
Victor, the loop it should be counterclockwise.
It's better to loop clockwise, but sometimes you can loop counterclockwise. If you loop counterclockwise, then you will have the same equation here. But the book is, you can use the book, you can use my approach. You can use both, but I prefer my approach. Any question about this KVL? Any question about it? Let's do an example. Which elements are in parallel? Well, we have D and F. No, A and E are not in parallel. No? It's only D and F. صح?
Yes.
It's only D and F. Now, if I tell you the combination of A and E is parallel with B, and the combination of D and F is in series with C, but this is beyond. But the question is clear. إذا سألك على السؤال, which elements are in parallel? He already told you. Elements, ما قال combination. Elements in parallel D and F. Which elements are in series? A and E. خلاص بس.
So A and B not parallel.
No, A and B are not parallel because they do not share the two nodes. ما هم متوازيين بالضبط. في واحد مخرب عليهم في النص E. الإي مخرب عليهم.
A combination of A and E.
الكومبينيشن هذه بعدين. الحين هو قال elements. الكومبينيشن ما يحتاج تقولها الحين، بس بعدين في المستقبل حنمر عليها.
What about B and C?
B and C, they are neither. Neither. B and C, they share a single dot but with other elements.
البي ان دي ما قلنا انهم بارلل لان في بينهم element لو سي صح؟
صح، B and D ما هم برا لأن السي مخرب عليهم. بس الخلطة حقت ال A وال E هي parallel مع ال B. والخلطة حقت ال D وال F هي سيريس مع ال C اللي هي كلها سيريس مع الخلطة حقت بنخش في متاهة احنا في غنى عنها. السؤال واضح. Elements ما قال combination of elements. تمام؟ بس إذا أنت فهمت ال combination من باب أولى تفهم ال elements. So any question about this? بعدين معطيك. Given that VA is 10 volt, VC is 15, VE is 20. لا VC is 15, VE is 20. when VE 20 طلع ال VB. Make a loop. So we have B, A and E. Let's do loop 1. هذه أول. I am here. Well, the question is find values of VB and VF. خلينا نلقى أول VB. Oh, what is the relation between VD and F? Okay, what is the relationship between voltage VD and VF?
Same.
Not the same يا شباب. This plus, this is what? Plus here and minus here. So VD equal to minus VF. So VD equal to minus VF. Why? Because polarity is reversed. And yes, they are in parallel. واضح? So the only elements that are in parallel is D and F and D. Now the question is find VB and VF. خلينا نبدأ بال VB عشان نعرف ال A وال E. ناخذ لفة. وين تبغون نبدأ؟ نبدأ من أي زاوية؟ هذه ولا تبغون نبدأ من وين؟ خلينا نبدأ من هنا أسهل. نبدأ من هنا. آخذ لفة كلوك وايز. ما في شيء هنا. بعدين voltage rise ولا voltage drop؟ voltage drop negative. minus VB. voltage rise ولا voltage drop؟
Rise.
plus VE. voltage rise ولا voltage drop؟ minus VA equal to 0. هو already معطيني ال A ومعطيني ال E ويبغى الماينس V equal to 0. نودي هذه هنا VB equal 20 minus 10 equal to 10 volts. نحط الوحدات between brackets. That's VB. الحين عرفت ال VB هو يبغى ايش؟ ال VF. ال VF اعرفها اذا عرفت ال VD. خلينا نسوي لوب ثانية هنا. نسوي لوب ثانية؟ أي مكان تبدأ فيه ما عندك مشكلة. So we did this over the left loop. Now we go to the middle loop. Again, we start from here. It's better. Voltage rise or voltage drop? Rise plus VC. Voltage rise or voltage drop? Rise minus VD. عفوا plus VD. Yeah, voltage rise. بعدين عندنا voltage rise or voltage drop? Rise plus VB. ثق بنفسك في الجواب. ثق بنفسك في الجواب. Equal to 0. We already know VB. We already know VC.
Yes.
So we need VD. So VD equals minus VC minus VB. أحسن خلي الحروف إلى آخر شيء. What is minus VC?
Minus 15.
What is minus VB?
Minus 10.
So that's minus 25. That's VD.
We want to be
What is VF? We already know that VF is minus VD.
25.
So VF equal minus VD. So which equal to 25 volts. Volts. Okay? Don't forget the unit. So we solve this example. It's very easy to solve it, okay? Checkpoint. أحيانا ممكن يكون في الكويز بيخلط لك ال KCL وال KVL مع بعض. Any question before this slide? Now try to solve this example. لحظة يا شباب. هذه غير الأرقام ولا إيش السالفة؟ هذا exercise 1.9. Okay. هذا solve this exercise. We already solved the example. Solve the exercise. Yes.
Doesn't the sign, the negative sign indicate that our direction is wrong?
There is no wrong direction.
I mean, the opposite direction that we assume as the first.
ما فهمت سؤالك. اشرح بالعربي.
المفروض انه يكون الساين بوزيتيف حق الفولتج.
مو شرط، عادي، ممكن يكون نيجاتيف، ممكن يكون بوزيتيف، انت امشي على اللي قلت لك عليه.
لا بس يقصد انه لو كان نيجاتيف يعني دايركشن مختلف عن اللي افترضناه في البدايه.
المحصلة راح تكون نفس الشيء. يعني لو حلينا هذا السؤال ولفينا كاونتر كلوك وايز، قصدك لو لفينا كاونتر كلوك وايز؟
قصدي انه لا، مثلا احنا قلنا كانتر كلوك وايز طلع لنا بوزيتيف يعني كانتر كلوك وايز.
حتى لو سويت كاونتر كلوك وايز برضه بيطلع نفس الرقم. هي الفكرة كيف ترتب المعادلة. عشان ترتب المعادلة لازم تمشي على تصير كونسيستنت، ما ينفع تلخبط. فانت يا تمشي على نظامنا فولتج رايز فور دروب، يا تمشي على نظام الكتاب، اذا هي شفت سالب حط سالب، اذا شفت موجب حط موجب.
اقصد انه لو افترضنا انه فولتج دروب وطلع نيجاتيف فبيكون دروب نيجاتيف.
نفي اثبات، ما نبغى نخش في نفي اثبات. كانك تقول نفي اثبات، خلها زي ما هي. بمعنى لو كان عندك element، قصدك انت سؤالك لو element VA وكان بلس ماينس وطلع VA equal to minus 5 فولت، معناته لو حطيت البلس هنا والنيجاتيف هنا حيطلع 5 فولت. نفي اثبات، هل له لزوم؟ ما له لزوم. هو اوريدي حط لك الاشارات، وانا قلت لكم محاضره راحت، اذا حط لك الاشارات في اماكن لا تلعب فيها، بتغير بتلخبط نفسك وتلخبطنا معك، وبتختار الخيار اللي فيه تريك وبيروح عليك السؤال. فنفي اثبات ما له داعي في هالكورس. اذا حط لك اتجاه هو يبغى. لما انا احط الموجب هنا والسالب هنا، انا اقول لك انا في المختبر حطيت الموجب هنا والسالب هنا. لما حط الموجب هنا والسالب هنا، انا في المختبر حطيت الموجب حق الفولت ميتر هنا والسالب حطيته هنا. فكانك تقول لو انت عكستها في المختبر بعكسها هنا، لا ليش تعكسها؟ هو قاسها في المختبر كذا خلاص، خليها زي ما هي، خليها زي ما هي. تفضل.
بس ولا توضح وجهة نظر.
تفضل تكلم.
لا هو شرح ما في.
لا عادي قول. شرح سؤال؟
لا انت بشرح سؤال.
ايه لا، جاوبت على سؤالك؟ تمام. ما في سؤال يا شباب تسألون الحين أحسن ما تسألون في الامتحان. أسئلة الامتحان بتصير مرة ما فيها جواب.
فيزيكس 1 2 كان يعتمدون الطريقة هذه من طلع ماينس
فيزيائيين نفسيات. It's a concept إنه it's a way. كأني أقول لك يعني c زائد صاد أو x plus y equal to 0 minus x minus y equal to 0. It's the same equation. You just multiply both sides of minus 1. But I think with you, it makes more sense to say, is it voltage rise or voltage drop? And by the way, most electrical engineering professors, they use the physics 102 method or the book method. If you don't like it, use the book, okay? And send me email, I don't like it. That's okay. You're not going to lose points. So let's try to do the checkpoint. Use KCL and KVL to solve for the labeled currents and voltages in figure 144. Compute the power of each element. هذا السؤال ملغم. It asks about KCL, asks about KVL, it asks about power. So how to solve this problem? Well, we don't have enough time, but hopefully we will. كم رقمها؟ 1.44. So أنا بحلها applying KCL and KVL. Okay. We need to find IC. الدائرة ما هي واضحة بس. So IC خلنا نختار هذه الدوت. N equal out. لا نختار هذه الدوت. It's up to you. This dot or that dot? IC is not known, IB is not known, IA is not known. You know IB, you know IA, so use this dot. So N equal out. What is N? IC plus ID. خلي الحروف زي ما هي. Equal out. IA. So IC equal IA minus ID, which is equal to 1 minus 2. Minus 1 amp. We calculated this. Now at this node we can calculate IB. N equal out. This is lower node. N equal out.
زيرو.
N في تيار يدخل الدوت اللي فوق هذا؟ لا زيرو. equal out. IB
IB
plus ID plus IC. So you want IB, صح? Minus ID minus IC. What is minus ID? Minus 2 minus 1, which is minus 1.
So there is no need. It is negative to IA.
Or negative of IA. See? Saved 10 seconds during the test. صح? You can do it that way. That's a better way. I didn't see it. Now once we calculate this, we can do a KVL. So IA is 1, IB is negative of it. Okay? Now let's do a KVL. Which loop you want to go to? This loop. You know VA? Okay, what is VC? VC is 10 volt, parallel. ونفس الإشارة, plus minus, plus minus. VC is 10 volt. So let's do this loop. Voltage rise, KVL, around the left loop. So you have voltage rise, plus VA, plus VB, minus VC. What is VA? 20 plus VB minus 10 equals 0. So VB equal minus 10 volts. صح? So VB equal to minus, and VC, we already told you, VC equal VD equals 10 volts. Why? Because they are in parallel with same polarity. Now we finished the question about, we found all the voltages, we found all the currents. Now to calculate the power, which is the last part, can I take 3 minutes? And if you want to leave, you can leave. It's recorded in YouTube. So how to do the power? Start with element A. If you want to leave, you can leave. Power A. Passive sign convention. Option A or option B? Option 1 or 2 or 3? Option 3. Option 3, so you have minus VA times IA. You already have the numbers. What is PB? The power, what option is that? It enters from the positive and it's positive. So that's option 2. Or option 1. VB, IB. What is the power of C? Enter from the positive and positive. VC, IC. What is power of D? VD, I of D. Once you calculate all the powers, I can give you the answers. Minus 20, 10, minus 10. So this is going to be 10 watt. This is, that's minus 20 watt. This is going to be power of B 10 watt. And the other one is minus 10 and 20. If you sum all of them, minus 10 plus 10, 0, the summation is 0.
So it's conserved. It's conserved.
Power is conserved, and we use the options, as I told you, option 1. The only passive sign convention was at element B, because the current enters from the negative. That's why we added the negative sign. Power of A, sorry. Power of A. هذه قلنا ايش نسميها غصب. This is we imposed. So this question is a good question for the quiz. Okay?
في الالكترونيك KCL المفروض ID equal IB plus IC.
When N equal out, which node? هذه? N equal out?
IB equal IB plus IC.
IB plus IC plus ID, because they are all out. No N. We said N equals 0.
احنا قلنا اذا طالع من البوزيتيف كود الكرنت اذا طالع من البوزيتيف هو مرة طيبة.
I have to stop the recording.